29AK, the acid association constant Ka for propanoic acid has the value 1.35 times 10 minus 5 mol per dm cube. Write expression Ka for propanoic acid. Now, propanoic acid dissociates like this, so it's easier just to do a quick equation like that. So you got CH3, CH2, COOH. Dissociates in equilibrium, he'll be CH3, CH2, COO minus plus H plus. So if you do like that, then you can work out what's the expression of Ka. So Ka equals to products divided by reactants. So it's going to be CH3, CH2, COO minus concentration of H plus ions divided by concentration of CH3, CH2, COOH. So that's to answer that question. Calculate the pH of 0.125 mol per dm cube of aqueous propanoic acid 298 K. So the question is, what is the pH? Yeah. So they know the concentration of propanoic acid is this. So we have concentration of propanoic acid equals to 0.125 mol dm cube. Okay. So first thing you do, you're going to replace the equation. So you know Ka is 1. So put 1.35 times 10 minus 5 equals 2. Then you have what you do this here, because this is a weak acid, you change that to H plus squared divided by concentration of your acid, which is 125. So if you rearrange this equation, so you have now H plus concentration H plus ions equals to root of 1.35 times 10 minus 5 times 0.125. So that gives you H plus equals 2. Gives you 1.3 times 10 minus 3. Yeah, so that'll be mol per dm cube. So now we want to know the pH. So pH equals to minus log of hydrogen ions concentration, which is going to be pH equals to minus log of 1.3 times 10 minus 3. Therefore the pH is going to be equal to 2.89. And that's how you answer this question. Now the following question is this: sodium hydroxide reacts with propanoic acid as shown in the following equation. Right. A buffer solution is formed when sodium hydroxide is added to an excess aqueous propanoic acid. Calculate number of moles of propanoic acid in 50 centimeters cubed of 0.125 moles of aqueous propanoic acid. So all you have to do is moles equals to concentration times volume divided by 1000, because the volume is in centimeters cubed. So moles equals to concentration is 0.125 times 50 divided by 1000, which equals to 5.25 times 10 minus 3 moles. No, actually that's incorrect. It would be 6.25 times 10 to minus 3 moles. Right, the next question is to use the answers of part A3 and part C1 to calculate the number of moles of propanoic acid in a buffer solution formed when 2 centimeters cubed of 0.5 aqueous sodium hydroxide added to 50 of 0.125 of propanoic acid. Yeah, so we already done this calculation before. So there you are, the calculation done before. Here, so we got moles of propanoic acid that we calculated and gave you 6.25 times 10 minus 3. So we know the moles of sodium propanoic acid is that value there. So if I say 0, this is your propanoic acid, plus you have your sodium hydroxide makes your sodium propanoate plus water. So you know the moles of this is 6.25 times 10 minus 3. Moles of this is going to be 2 times 0.5 divided by 1000, which gives you 1 times 10 minus 3 moles of sodium hydroxide. So now if you react propanoic acid with sodium hydroxide, that's reacted, whatever was reacted from here, you have to subtract that away. So whatever is left. So you got CH3 left, or acid left, equals to 6.25 times 10 minus 3 minus 1 times 10 minus 3, which equals to 5.25 times 10 minus 3 moles of acid. Okay, so that's we done the first part. Second part here is work out the pH of the buffer solution at 298. So we know the moles of sodium hydroxide is here, so the ratio is 1 to 1, so the moles of your salt is going to be the same. So moles of salt equals to 1 times 10 minus 3 moles. Okay, so we need to work out pH, so you have to use the pH equation, which is H plus equals Ka times your acid divided by salt, so it will be your propanoic acid divided by sodium propanoate. Okay, so H plus is going to be equals to Ka is going to see in the first part of the question. Ka is 1.35 times 10 minus 5 times you got your concentration of propanoic acid, which is is going to be this one here, 5.25. Concentration of 5.25 times 10 minus 3. So that's moles divided by volume. Okay, so all that divided by 1.0 times 10 minus 3 divided by volume. So volumes cancel out, so that would give you the hydrogen H plus ions concentration equals to 7.088 times 10 minus 5 moles. Okay, for the MQ. So the pH equals minus log of that value, which gives you equals to 4.15. Right, this is how you do a calculation of buffer solution. So I showed you step by step from working out the weak acid, work out when you react the acid with the salt, with the base and getting a salt, and then work out the pH at the end.